All right, welcome back. So apologies for the breakouts and for the long um silence. So it was some technical issues I had to quickly attend to. My sincere apologies. All right, so yeah, let's go into what we have for today. Let's go into what we have for today. So I'll share my screen. Um, all right, so yeah, we'll be making use of this Medium article. So this is going to be our guide. All right, so I randomly found this article during the course of the week. All right, and it's just an article that about VLAN trunks and inter-VLAN routing with router on a stick. Right. So yeah, this is by Angel Salas, right? So special shout out to Angel Salas for this beautiful article. I have glanced through it, right? I've glanced through it, and it's going to be a fun one, right? So he's an IT support specialist and cybersecurity researcher. So shout out to Angel Salas and shout out to CyberGuard malware and vulnerabilities analysis. All right, so you can check this out. I'm going to provide a link to this write up after this stream. Yeah, I'm going to provide a link to it. All right, so let's go over this. Right, so it's quite doesn't seem like a lot, but yeah, let's just go. I can see it has three different demo labs. All right, so yeah, also in this we'll be using no we'll be using the partner to break down and understand some things. So our partner is our AI. um to- right. So but for now, let's come back to the article. All right. So what does this person have for us as regarding mastering VLAN trunks and inter VLAN routing with router on a stick? All right, so it says as network grows and evolve, right, proper segmentation and effective inter-device communication becomes essential. All right, in modern LAN environments, right, this is most effectively achieved through the use of VLANs, right, trunk links, and inter-VLAN routing techniques such as router on a stick. So in this post, we'll walk through a live network scenario showcasing the configuration and verification of VLAN trunks and sub interfaces on a router. Alright, so let's see mastering VLAN configuration with Cisco iOS. So it says VLAN, which is virtual local area networks, right? Used in network engineering to logically segment networks at layer 2 of the OSI model. Alright, this segmentation allows for better traffic management, security, scalability, and efficiency without requiring additional physical infrastructure. Alright, so I think this is quite straightforward. Alright, so if you have a background, you know, knowledge, understanding about networking, alright, this is going to be quite simple to grasp. And for for our viewers who with basic technical knowledge, let's just say a local area network is the area is the network, just like the name, it's a local area network. it's a network that is just restricted to a very limited geographic region, right? Just for example, um, maybe a network within just an office, right? So a network within an office, or a network within maybe a small campus or so, right? And now we'll now talk about virtual local area network, right? This one now deals with how we segment this network, right? A single network which can now be segmented into different, let's say for example, in a bank, right? So we have the banks, they operate on both local and metropolitan area network. But for the local area network of a bank, right, so we're going to have let's say we have the maybe the cashiers, right? We have the cashier network, a different segment of the network for the cashiers, and we have for the manager, then we have maybe for the IT team and all. But all of that is within just the office. Then that's what the virtual local area network um, gives us, right? So it helps us to segment our network for better traffic management, security, scalability, and efficiency, right, without requiring national physical infrastructure, right? So that's pretty straightforward. So going into our lab scenario setup, say you are a network engineer for a growing organization. Initially you have two network segments, which is employees and guests, right? So now the new requirement for the network says we need IoT devices, right, isolated from other traffic, and we need to expand the network for new users in other parts of the building, right? So these are lab scenarios, quite straightforward, right? So initially we are just two segments of the network. All right, and that's just employees and guests. All right, then now we need to create IoT devices, and we need to add IoT devices and remove them or isolate them from other traffic. That's traffic moving between employees and guests and likes. Then also we need to expand our network for new users in another part of the building, right? So that could be us setting up a another VLAN for the other part of the building. But let's get into it and see what we have, right? So these are lab index, and the demo one says a network without VLANs, right? Ping behavior and segmentation issues. So in this lab setup, we connect employee, guest, and IoT devices to separate unmanaged switches, right? So we are going to have employee switch, guest switch, and IoT switch. Right, so each group is assigned a unique IP subnet. Right, so this is the IP subnet uh for the employees network, this is the IP subnet for the guest network, and this is the IP subnet for the IoT devices network. So despite the subnet separation, the absence of VLANs means all devices share the same layer 2 broadcast domain. So when we run ping tests between devices across different subnets, such as from an employee PC to a guest PC, we observe successful replies. So what this basically interprets to is that okay, now even though our subnet has separated these devices, into different subnet addresses and even network addresses, right? So, however, when you try to ping between maybe, for example, the employee, a device in the employee under the employee switch, you're trying to um, ping. You're trying to ping through a device under employees. You're trying to ping to the guest to another device under the guest network, right? So it's still going to be successful because we have just the only separation we have here is just the subnet, right? It doesn't restrict the communication, right? So the ping is still going to the ping test is still going to be possible. um so this confirms that unmanaged switches do not enforce logical boundaries, right? So and all traffic is freely forwarded regardless of subnets, right? So this behavior reveals key issues: no isolation between device groups, unrestricted broadcast traffic, and increased risk of cross-segment interference and security exposure. Right. So these are just the risk with having a open switch, right? A switch that is not logically partitioned or segmented. Right. So, and I think this first demo is to see create the topology in Packet Tracer. Right. So it says demo one, a network without VLANs, right? So first thing we want to do is we want to create this topology, this physical topology, and configure SIM on. We need to configure SIM on our Cisco Packet Tracer, right? So it's going to be without VLAN. So it says our note for this setup to work, we need to create a router and a stick, a router on a stick, and assign the default gateway, the host according to their subnet, right? So let's first draw this setup, right? This physical topology. So let's first construct SIM on. Let's construct SIM on our. Let's design SIM on our Cisco Packet Tracer, right? So we have a router, a switch, okay, a router and three switches, then three devices. So let me just bring in this router, then switches. So to bring in three switches, two, three. Then let me just do this way. So from here, I want to add my own devices. So let me just bring in a laptop, and a laptop here. Alright, so let's connect this. So using straight stroke, so I can connect this to. Okay. So I need to add a module. So I need to add an extra module to this. So let me power this off first. So what do I have here? Okay, so I'll go with this. So this gives me 4 additional switching ports. And so I can turn on my router back, and now let's connect. So yeah, I now have 4 fast Ethernet ports. Alright, so let me just use the gigabit Ethernet for this. Alright, then I come here, I can add gigabit Ethernet for this too. Then okay, then the last one can have fast Ethernet connected to gigabit Ethernet. Right, so that's gone. Alright, then next, let me do this fast Ethernet to fast Ethernet, fast Ethernet to fast Ethernet, fast Ethernet to fast Ethernet. Okay, so yeah, this is physically okay, but not logically okay, because we've not done the configuration. So we need to configure our router, but before that, let me see what's in the documentation. Uh, Okay, so let's configure this without configuring our switches. So we'll just configure our router, then proceed to configure our end devices, right? So let's just do this first. So because this particular demo says a network without VLANs, so we won't be configuring VLAN yet. So let's just configure this. Yeah, I can just come and segment this by look. Select field color. So I can draw this. So let me change this color. So let me draw for this network also. And lastly, okay. So we'll go to this. So let me just delete this. All right. So let's just quickly configure this so I can come here. So also comes to my command line interface. So we won't be doing too much here. No. Sounds to enable conf. All right. What's name? Um, should we make this name? Let's say choose net. Um, then network is out of bound. Then welcome to choose net. Okay. So let me just change. Let me change the symbols I used here. Okay. Let's see. So just trying to write it in a different way, but still, I could be wrong. But oh, sorry, found the error. Banner emoji. So that's keep my mind. All right, so I have my welcome message now. Let me just clear this off. So what's next from here? Can do password, right? I enable secret password. That's 123. Nice. Let's write our configuration. Okay, so next thing I can now let's configure this. Let's configure these interfaces. But before that, let me just let me identify the interfaces, so it's going to be easy configuring them. Right. So we have this first one for employees. So you can see employees and 192.168.1.0/24. Alright, so we'll have same for what's this network going to be about? So this for guests. So I can come here and say, oh, guests 192.168.1. This is going to be .2.0/24. And lastly is for IoT 192.168.3.0/24. Alright, so we have this. Alright, this will make our work easier. So I can come to my router now. So I can say interface. So first thing I want to configure is this interface. That's this gigabit 0/0. So I going to interface gig 0/0. I can say IP address 192.168.1.1 then 255.255.255.0. Alright, so I do no short. So the interface is up. Alright, I can go into the next interface, which is gigabit 0/1. Right. So we can just 0/1. Right. Just change this. So 2.1. Right. Then no short. Alright, then the last interface, which is fast Ethernet 0/0/0. So Ethernet FA 0/0/0. Alright, can on to okay, no, this is a switch. Okay, yeah, I still need to configure it. Address 168.3.1. So, what could be wrong? Fast Ethernet. How am I unable to configure fast Ethernet? So, okay, so this person, oh, I think I'll have to change it. I need to change that phase, that port to a gigabit internet. So I need to change the module. Alright. So first, let me remove this connection. Physical. So turn this off. So let me see which interface has I think this does. serial ports. Okay, I think I'll have to change the router. So let me change the router, so that's an extra work for me. Alright, so let me use 2911. I believe this should have up to, it should have up to 3 gigabits Ethernet support. Okay, so this satisfies my need. So okay, just have to delete this. Yes. Okay, so we're good. So let me come back and start my configurations afresh. Alright. So let's start configuring the interfaces again. Alright, so I want to go to interface gigabit just a 0, IP address .1.1. So I think that's going to be all the configurations for a router, or maybe for now. Alright. So your next thing, let's just go to assign IP addresses to all of these devices here. Alright, so let me come to this first. Let's say this is that. I think 11 was used here. Okay, yeah, so let's use same thing. So dot 11, that will change our gateway. 192.168.1.0. So let me try and ping the router first. Okay, so that's successful. So let me just quickly configure other devices here. Mm, no, before that, sure. Okay, so now we're done with configuring all of these devices. Alright, okay, so let me just add name into this. So this is our, oh sorry, the names are there already, so no need. So this is our employee, guest, and IoT. Right, so we've achieved all of this. Right, so now let's try and ping. Let's try and ping. We'll run ping tests between devices across different subnets. So such as from employee PC to a guest PC. It gives or it returns successful replies. Right. So these are just this entire network is just differentiated by different subnets. You can see dot 1.0, dot 2.0, and dot 3.0. Right. So but now let me just try and ping. Let me try and ping this IoT device from here. All right. So I want to ping the IoT from the employee. So that should be dot 3 dot 11. So let's see if it's successful. If it's successful, then it means there's no logical segmentation running on our network yet. Right. So I can now do ping 192.168.3.11. Okay. Quest timed out. Okay, so okay. Um so I understand where this is coming from, right? So we've not done the RIP configuration of this network, right? So that should be where the error is coming from. Yeah, that should be, but nothing speaks about that here, right? But I think yeah, that must be where the error is coming from. Okay, but I think before we do that, okay, let's configure router on the stick first before. So I don't want to make it look like maybe I'm jumping off. So I don't know if configuring our routing protocol is needed in this lab, but I feel it's needed because without the routing protocol, right, whether RIP or OSPF or whichever, um, these devices might not be able to communicate. But let's just follow this. let's follow this setup here first. Right, so let's follow this setup here first. So let me come back to my router. So yeah, I just do exit. So from here I want to do interface gigabit ethernet 0/0, then /0.10. All right, dot 10. Okay. Okay, so we now have something different. I'm definitely seeing this for the first time. Not gonna lie, because I haven't played around router on this before, and this is my first time, walking around these, and I'm basically learning it afresh too. So it's fun stuff. So I've seen config if, but config sub if, well, that's new. So but let's follow up with this. So next command says encapsulation dot 1q, and this is going to be 10. All right, encapsulation dot 1q 10. Then what do we need to do? Assign IP address. This is going to be 192 dot okay, I just IP address 192.168.1.1, then 255.255.255.0. Let me just confirm this. Okay, so let's run this. So it says overlaps with gigabit ethernet 0/0. uh what's the IP that was set for this? Oh, okay, I think I not supposed to set an IP address? Was I not supposed to set IP address for this interface? Hmm. Because it says it overlaps now. Okay, but before we proceed, so let's just understand what this is used for. All right. So I'll just copy this and give to my friend. Hey, you can say I'll explain what this is used for. In, oh no, I'm not signing in. This for my stream. Explain what this is used for in a router on a stick setup. Okay, so let's see what our friend gives us. Okay, so that snippet is configuring a sub interface on a router for a router on a stick setup. Alright, so here is what each line is doing and what matters. So this creates a logical sub interface of the physical interface, and the content shows a label which by convention it matches VLAN ID 10. Okay, so let me ask. Okay, to use a router as um, router on a stick. A stick, comma. Do I need to assign IP addresses to the interfaces? Um, let me just zero, just like zero. It's raining heavily right now. I mean, crazy heavy, and I don't know if you can hear over the stream, right? It's raining crazy heavy right now. I hope this wind will not blow me away from here, but it's crazy heavy. And no, as usual, our electricity distribution company, they've taken the light. So let's see. I hope it doesn't affect internet for this stream. But let's continue with our stream, and let's enjoy what we're doing. All right. So I'm trying to see how yeah, we're still trying to find what the problem could be. I still trying to see what the problem could be. So see, yeah, do I need to before setting my sub, what do you call this for? It's called it a name for us. Yeah. So sub interface. Let's say width or okay. So let's see what our good friend wants to say. You do not need IP addresses to the physical interface when doing router on a stick, or what you should do instead. Okay. So all IP addresses go on the sub interface, not the parent interface. Okay, so I need to remove IP addresses from these interfaces now. So let me just um, I need to exit this first, and int 0/0, you can say no IP address. Right, so I've removed the IP address then. So let me now go back. Oh, let me just remove from all of them. Int gig 0/1, no IP address. Int gig 0/2, and say no IP address. Alright, so we've removed all the IP addresses we assigned earlier. Uh, okay, I hope we're still live. Yeah, still live. Good. So thank you for sticking. Thank you for sticking with us. Let's continue our configuration. Then no IP address. So now let's configure our sub interface now. So in order to do that, we just come to interface gigabit 0/0.10. Right. So I can now assign IP address again and say, oh, encapsulation dot 1q 10, then IP address 192.168.1.1 255.255.255.0. Right. So now we have assigned an IP address to our sub interface. Alright, so what else? Okay, so we just repeat the same procedures for the remaining segments. I mean for the remaining switches, right? So let me just go to interface gigabit 0 slash um this should be slash 1 point, okay, 0.20. Oh, sorry. Yeah, 0 point. So I can undo encapsulation. Can I do encapsulation dot 1q. This is going to be 20, I think. Yeah, that's 1q20. Then I can do what's the next IP address? 192.168.2.1, 255.255.255.0. I think, yeah, that's correct. This rain is raining crazy, raining crazy. So next interface gigabit 0/0 point. Oh, wait. Okay. 0.30. Okay. Sorry, this is just, I don't know. It's not really messing with my head, but I was thinking I'm making a mistake. Right. So yeah, encapsulation dot 1q. Then it's going to be 30. Alright, gonna do IP address 192.168.3.1, then 255.255.255.0. And so we have all of this. So let me just do write memory. So now how do we test? How do we test if this is working? Let's ask our friend. So yeah, okay. So how do we test if um, this is effective? If the all right, so here uh, so this is what we have, basic idea of the test. You want to confirm devices in different VLANs can communicate. That's correctly. So check for IP configuration. Use network. Mhm. Okay, want to confirm if devices in different VLANs can communicate. The router is correctly acting as the gateway for each VLAN. So um let's check this. All right, so let's try and ping these devices now. So let's try and ping this laptop under our IoT devices. So let's try and ping it from our employee laptop. So ping. Okay, that was the last command we ran. So it says request timed out. Request timed out. So what could be wrong in configuring our PC? Right, this is going to be the IP address and the gateway. Okay, okay. So let me just change this. So let me try and ping this employee PC from the IoT devices. Let me just come here and say ping um 192.168.1 dot. I think this is okay. So this is 11.11. Okay, so request timed out. So let's see what could be wrong. What could be wrong? What could be wrong? What could be wrong? So each device should have an IP address in its VLAN subnet, the correct gateway. But let's try and ping. Let me try and ping dot one. So dot one should okay. It's not working too. But its own interface should be working. Okay. So let me do dot 3.1. Dot 3.1 should work. So if dot 3.1 is not working, then maybe I'm in big soup. Let me see. 192.168.3.11 60.3.1. I think something is misleading. Something is misleading. I have big doubts. Okay. Uh, this. Okay, so where could the issue be coming from? So let me just change to dot one. So our gateway is dot 3.1. Uh, and our IP address for the PC is dot 3.11. So key issue. Let's see. So if you have an idea of what the issue could be, you can just drop your suggestion in the comments. Right, you can drop your suggestion in the comments. Let me try and figure this ping. Okay, so this is not going to. Let me go about this from PC. Let's see that's 10. All right, so let's try and troubleshoot from our router. All right, so let's try and troubleshoot from our router. So from here, so it's no short. So what's this? So show IP interface brief. Right, so let's try this first. Show IP interface brief. No, sorry. Let's go to my privilege exec mode. Okay, so this up. Alright, so what's the results? Okay, yeah, so this is correct. So let's go to see our routing table. Now, this was what I suspected at first before we even went to before we discovered that, oh, the error was from the sub interface. Alright, so I can say, oh, show IP route. So no routing. Okay, connected to directly connected to this, and this is directly connected to this. Okay, I think we're good. Directly connected to network server. Yeah, that's correct. This is correct. So what else? Switch side. Hmm. Show interface trunk. We've not configured our switches at all. So is this still valid? Is this still valid? Um, so show interface trunk. Getting nothing from here. So what could be the issue? Could be the issue. Let's go back to our documentation and see if there's something. So the router creates a virtual environment, virtual server interfaces for each VLAN. Or could it be that this particular demo is to give us issues? Because I don't know, it looks incomplete. Let me see this. So demo 2, configuring VLANs and access ports. Segments network logically using VLANs in a single managed switch. Okay, so let's just try this. Right. So normally devices outside um this network shouldn't be able to communicate, right? So that's the correct thing with a VLAN, with a successful VLAN configuration. Well, let's try and let me add another device into this network and see if both can communicate. Then if it can communicate, it means we have achieved what we've achieved the goal for this particular demo, right? So let me just configure this, and so I'll make this dot 12. So let me ping dot 1.11. Okay, so it's successful. So this means our segmentation is actually working, and no, it's successful. I think it was just either either of these, no, our two sources was the misleading one, and that's most likely our friend ChatGPT. Because what this gave us was, if when your this thing is successful, then so it says check IP configuration. So you want to confirm devices in different VLANs can communicate. The router is currently acting as a gateway for each VLAN. So yeah, we don't need them to communicate, or maybe the English wasn't just right or something. But yeah, so our network is up and running, right? So it means devices inside only devices within this employee network can communicate with each other, and no, proper segmentation has been implemented here. All right, and I think this is good. This is good to go. So let's go into our second demo. Let's go into creating our second demo. So let's say our second demo. So the second demo says, oh, configuring VLANs and ports access, or access ports. Sorry. So the goal of this demo is to segment the network logically using VLANs on a single managed switch. So let me just quickly do this. So let me just name my first demo. Right. So just for this. So now let's create our second demo topology, or topology for our second demo. So here we're going to have just a switch and the different devices. So I think I'll just have to add two devices for each network. So I think it makes more sense in that way. So let me bring my switch in. I can bring my end devices. One, two, one, two, one, two. All right. So we have this. So what we want to do from here is just this. So let's connect all of these ports. So I'll connect fast Ethernet 1 to this. Then fast Ethernet 2 to this. Should I use fast Ethernet 3? Or let me skip this to, let me just reserve. Okay, we have 24 ports, right? So let me reserve 1 to 8 for this segment. Then let's come and say, oh, from fast Ethernet 9. Then I'll assign fast Ethernet 10. Oh, how was it done here before I go do mistake again? 1, 2, 3, 4. It's pretty straightforward there. But let's just use it in this way. I'll just do it in this manner. So I'll do 17. All right. So we have this. Okay. So let me just come and shade my different segments. Let me just use this color. Then let me change the color for this. Okay, so we're good with that. So this is going to be VLAN 10 for employees, VLAN 20 for guests, and VLAN 30 for IoT devices. So before we proceed, let's just go over this right up. So it says, in this demo, we transition from a flat network to a segmented design using VLANs on a Cisco 2960 switch. Now the goal is to logically separate employee, guest, and IoT traffic while maintaining physical connectivity. Alright, so now all of the devices are connected to just a single switch, right? And we want to implement, our VLAN segmentation here. Alright, so VLAN segment we define three VLANs. So VLAN 10, 20, and 30 access ports. Alright, so we'll do this now. But before then, let's just quickly fix something.